Hello, everyone, and thank you very much for joining today's show. My name is Quentin Anderson, and today we have assembled a panel of experts in various fields that are all related to pixel streaming. So today is a live show, and we have the opportunity to explore multiple topics with our experts on how they think and approach certain projects and workflows when it comes to pixel streaming. And today's objectives for the panel are first for us to explore and consider how pixel streaming applications have evolved over the past 3 years. And then we'll also define and develop key metrics from inception to going live and thinking about what that process looks like as we move through it. We'll also look at some operational and internal processes that are critical for a successful pixel streaming project. And then once your project is in the market, how is it going to be benchmarked against others to make sure that you are standing above the rest? As always, these are live shows and we highly encourage participation. Please, if you have any questions during the show, please don't hesitate to submit them to us because we are happy to answer them during the show. It's very easy to do. Just drop the question in the live chat and our moderator, Jay, will make sure that he answers he gets the question to us and then we will answer it for you. If you would like to address a question to a specific panelist, just let us know by writing their name. So for example, David, and then the question, and then that will make us know that we will address it to a specific individual. Before we introduce our panel, we'll quickly go over the agenda. So we have 4 segments today. The first segment is we will meet our panelists and they will provide a little information associated with some of the work that they're involved in. And then after that segment, we will transition to the second one, which is perspectives. And we will ask targeted questions to all of our panelists about some of the work that they're involved in. In the third segment, we will ask some what-if questions to our panelists to hopefully provoke some thought-provoking ideas and discussions with our experts. And then finally, of course, we will conclude with a live Q&A. And of course, if you have any questions before that, don't hesitate to submit them, but then we'll also have an opportunity to go over your questions at the end of our show. So, to introduce our panel, first we have Ludwig Loven, who is a solutions architect at WSP. Ludwig is trained as a structural engineer, and his career started doing BIM and architectural visualization. And then in 2015, he discovered Unreal Engine and has been fiddling around with it ever since. Currently, Ludwig leads the software development team at WSP, Digital and Information Management in Sweden. And when he's not working at his computer, he loves to play guitar, ski, and mountain bike. Thank you, Ludwig, for joining us today.
Thank you.
Next, we have Bosco Bellinghausen. He is the co-founder and chief metaverse architect for Metaverses. Bosco is one of the leading metaverse experts from Germany. He is the co-founder and chief metaverse architect of Metaverses, which is a new virtual world. In 2020, he started to experiment with pixel streaming and cloud technologies as well and released his own virtual world, which was 100% pixel streamed that same year. Bosco, how are you doing today?
Thank you very much for having me, Quentin, on this fantastic panel. Really looking forward to it.
Wonderful. Thank you for being here. Next, we have David Burnett, who is the founder and director of Invidar. David is a multi-award-winning real-time specialist building the next generation of platforms for the metaverse as founder and director of Invidar, with a background in game development and technology focusing on XR platforms and interfaces with Unreal. He is an avid PC enthusiast and UE tinkerer and lover of games. David, thank you for joining us today.
Thank you for having me.
Next, we have Jacob Feldman. He is the software and rendering solutions engineer at CoreWeave. and Jacob, combining a love and mastery of science, art, and technology to revolutionize digital experiences that inspire, inform, and innovate. He leads the software and rendering team over at CoreWeave. He is currently developing next generation cloud native solutions at CoreWeave for VFX and games, and is an Unreal authorized instruction partner for Epic Games. Jacob, how are you doing today?
I'm doing great. Thank you for having me.
Absolutely. Wonderful. So now that we have our introductions out of the way, we can go ahead and get started with the first segment where we will get to know our panelists a little bit better. And so I'll call on the panelists one by one and ask them to share a little bit about their work and background so that we can have a better understanding of their focus and interests. So Ludwig, we have you as first, if you'd like to have the floor and take it away.
Sure, like 5 minutes or?
Yeah, 5 minutes, 7 minutes, however long
All right,
it needs
we'll
to
see.
be. Yeah.
All right, yeah. So I got into game engines, Unreal Engine, pixel streaming, all that around 2015-ish. So that's basically when I developed or deployed my first pixel stream, the Unreal Engine application, and so that was for design coordination of infrastructure projects. So basically the first attempts was basically one Unreal Engine application with no outside connectivity packaged onto one virtual machine in the cloud, and you had to take turns and log into it one at a time, and that's kind of, easy and straightforward to do. But then as you're adding complexity to that, okay, we want multiple people to be able to access this at the same time. So then you need some sort of, scalable system that can add and remove machines as people log in and out. And also, if you want to update the data, you want some live connectivity to that. Because like in those days, what we did was we packaged all the project data as a standalone app in the engine. But that means, we had to deploy it all to the cloud with the data, and there's a huge file size and all of that. So, from there, it's kind of gone to being a more distributed system where if you want to scale this, you need basically a whole cloud architecture to deal with all of that. Like if you want to load the data in at runtime, you need first to have an app that can support that. Then you need to be able to store, translate, version, and stream data in the cloud backend. And also, if you want like real-time IoT data connectivity, you need all of that set up, probably in a cloud provider. So all of that really adds complexity and adds, what your product needs to do. So right now I'm sort of looking at the next step, scaling it even more and adding in more stuff on the back end that sort of feeds the front end. In the end, you have the user interacting with one pixel streamed instance. But then behind the scenes, you can do all kinds of stuff, with the IoT hubs, with the data streaming, data translation. You can have AI doing calculations and just feeding it to the front end. So that's sort of where I am looking at right now.
Oh, wonderful.
I don't know. Any questions on that?
Well, I'm sure the audience are going to have plenty. And then one more thing just to note. So Ludwig is our digital twin expert that is on our panel today. I know it's kind of a big question, but can you briefly just share and explain to us what a digital twin is?
Sure. And that's a term that's in the last few years been transitioning from buzzword into something that's actually usable. So, I would say it's a 3D model representation of something and some sort of data coming in that represents the state of that 3D asset that is linked to the real world. So it could either be, historical data that you're feeding in. It could be like real-time data from like right now, what's the status of this one right now, or it could be future data based on the state of the twin at this point. What's it going to look like in the future? Simulate things, simulate and predict, and any of those use cases, and it can be applied into all kinds of industries. I'm mostly in the AEC space, building cities, infrastructure, but it's being applied in manufacturing and automotive and all kinds of industries as well.
Absolutely. And the use cases are almost endless. And I know that we'll get into digital twins a little bit later on the show, but thank you very much, Ludwig, for the presentation. Unless there's anything else, we will go to our next panelist.
Go ahead.
Thank you, sir. Next, we have Bosco. Bosco is our Metaverse expert today on the panel. Bosco, thank you for being here. Would you like to share a little bit about some of the work that you're involved in?
Yeah, sure. I mean, first of all, I started back in 2019, and I had the vision in my head to create really high-polished, almost hyper-realistic virtual environments. And let me show you. I just recorded something which was really running already on Pixel Streaming, but if I would do it now simultaneously within the stream, within live stream, then we will probably get a little internet problem here. And so let me just share what we're working on. So I'm the chief metaverse architect of Metaverses, and we are creating a complete new virtual world, so to say. And everything is pixel streamed. So as you can see, the reason for this is accessibility, because I think it is very important nowadays that almost everyone with a fast internet connection and a screen can participate in virtual worlds and can experience those virtual worlds without having a hardware at home or another hardware device. And so this is the whole idea. And yeah, what you can see, actually, this is an experiment because this is actually a virtual world which is around 12 gigabyte huge. So everybody knows in terms of developing virtual worlds, this is a quite huge map, so to say. But we kind of got it up and running with some tweakings and performance optimizations. Here it's real time, so yeah, it takes a little bit until everything is loaded. And of course, it's the pre-alpha stage, but what you actually will see is or will become our alpha, and we will release it very soonish, so that everybody really can just check it out. And now here we are. And now the avatar system is loading. So yeah, bear with me. This is, as I said, it was a really live recording, but I don't want to, filter it or make it nicer. It is what it is. But you can see it's a very smooth experience and a AAA experience. So our idea is really to create virtual worlds which so to say have a little bit of the next generation aspect, which you normally would see in other games. And the principle is here a huge map, and you can teleport to different places. And just to show you even the performance, for example, you can ride cars, customize cars, do racing stuff, and just to show you that even, as I said, this is really pixel streaming live, and you see there's almost no latency at all. And I think that's so fantastic, because everybody really with a fast internet connection and a screen can enjoy this kind of quality at home. And I think that's very, very important if we're talking about the next steps of where we're heading in terms of virtual worlds. This is, for example, another experience, because I think a virtual world or metaverse-like experience needs experience. And so we fill in a lot of different stuff. For example, we have the skateboarding. Here now you can see that we have horse riding implemented, because I think it's just a a different way of moving around within a virtual environment, which is not yet there in every world. But I think it's like the reality. I mean, in reality, we do a lot of funky stuff and fun and entertaining stuff. But for example, horse riding is, I mean, in Germany, it's quite a privileged sport because a horse costs a lot of money. And within a virtual environment, everybody can, so to say, get the privilege of enjoying some kind of such experiences. This is, for example, a club, and as you can see, the lighting adjusts because if I go into a club, then it's probably a little bit in the nighttime. And now check this out. If I now go to the beach, then the daylight, so to say, adjusts automatically, so that I always have, so to say, a frictionless experience everywhere where I am. So if I'm in the club, I have the night feeling. If I'm outside, I have sunlight or rain or whatsoever. We can adjust this. And now I have a look. I mean, flying is one feature as well, but I just flew around because just to show you the dimension of what we already created. So this is actually a really world or the first level, so to say. And as you can see, it's huge. And to get this on pixel streaming was quite a challenge. But yeah, we kind of, I think our whole team did a fantastic job. Spent some really hardcore nights on solving some issues. But I think now it's really a nice experience. And this is what we are doing at Metaverses, and and that's why I'm a huge fan of pixel streaming, because it's so cool. So that you really have this triple A experience and opportunity accessible, so to say, for nearly everyone. And that's why I think, it's a very good way to go. Alternative to a normal game client, so that everybody really can enjoy different virtual worlds. I mean, this is just one virtual world, and the principle is actually that you will be able to teleport yourself into totally different worlds, which because we don't have time for this, which I can't show now. But as soon as the alpha is out there, you can test it for yourself and have a look, so to say. And I think that's what I'm doing right now. And I think that's it for my side, so to say.
Awesome.
For the demonstration.
Yes, and thank you for that demonstration. A few questions came through that I'll go ahead and send your way. So the first was, why not kill blur on movement? Pixel Stream already blurs the quality, smiley face. Just a thought, great demo though.
I did not get that. Sorry, I'm German. Bear with me. Can you please repeat the question?
Yeah. So the question is about motion blur. It appeared in the demonstration that motion blur was enabled in your experience. Was there a decision around that, whether to have motion blur enabled or not to have it enabled?
Actually, it's not finished yet. And so this is really the development stage. And if it comes to me, if I develop, I always deactivate motion blur for sure. And let's see. But as I said, this is the development, the latest development. But the tweaking, the polishing, this will come probably in the next sprint. So we are quite close, and then we'll get rid of all the, so to say, disturbing stuff.
The next question is, what is the minimum connection speed required?
This is a good one. I would say a 50 megabit connection should be available to have a proper experience. I mean, we even tested it a little bit with a smaller bandwidth, and then what we actually do, we scale down, so to say, the quality of the overall aspect, so it gets scaled automatically. So because we would like to try, even if you have a not that fast internet connection, that you still have a good experience.
Wonderful. Next question is this running with UE5 on all browsers and devices?
I mean, this is actually a UE 4.27 experience, but we will switch definitely, and we are already testing some other worlds with UE5, because as you saw, this is a huge map and all the lightning which is going on there. Then yeah, if we switch to UE5, we will definitely get some better results in terms of the performance, because we can tweak and play a little bit differently because of Lumen and Nanite, which offers so much power. And but yeah, as I said, we are in the development stage, and I rather did not want to push my guys to switch to UE5 now, because they need to finish what they are working on, because they are doing a brilliant job. And but after this, after the alpha release, we will directly switch to UE5. This is for sure.
Wonderful. And it looks like we have one last question for you. Are all the environments uploaded at once?
Yes, I mean what you saw. This is completely one level. I mean, this is the biggest level. We probably, I mean, with UE5 we can probably create even bigger worlds. But the other experiences which you will see, the other worlds, we have a. I know I can't spoil this. We have some other worlds. They are a little bit smaller, but everything what you could see is real time. And of course, we are using level streaming for different parts of the world. For example, the club, the horse riding area. This is all level streamed, so it gets loaded as soon as the user are entering a particular area of the map. Then it gets loaded, because if it would be loaded 100% all the time, then we get a huge performance issue, or we need a huge machine which is able to power it.
Wonderful, wonderful. We had a few more questions come in, and thank you everyone so much for all these awesome questions. We're going to catalog these and then address them once we get to the open Q&A, just to make sure that we get through all of our presenters' presentations. But thank you everyone for all these wonderful questions, and Bosco for your presentation.
Thank you.
Great. So we will move on to our next presenter, our next panelist, which is David. So David, the floor is all yours.
Hello. So just a bit of background on myself. And I've been using Unreal Engine for the last 10 years, ever since it was called Unreal Engine Development Kit, which would have been UE3. And my background is primarily from the educational point of view, so learning game technology, a lot with Bournemouth University, where I've done a lot of research in kind of interfaces and eye tracking, and looking at various modes of XR and kind of immersive technology overall. I've typically been trained as an artist, so I moved into Unreal Engine development and doing code, and now I've got the team at Invidar, where we are developing platforms predominantly for business-to-business corporations, for internal platforms, for Metaverse-esque and sort of 3D configurator projects. We are looking at projects in the Metaverse as well. And doing a lot of research and development in how we can stream VR over the web, both with pixel streaming and 3GS, and top of a lot of other projects that we're looking into as well, with kind of digital twins, a lot of what the industry is kind of trying to do at the moment. So, but the difference from what we do is it's usually for kind of virtual events and sort of B2B customers, so which I'm sure we'll go into later. But and I'll have some examples as well. So.
Okay, wonderful, and thank you for that introduction. And just to give some of the background on David, he is serving as our B2B and B2C expert today. He has been involved in some very big projects, probably some of the largest pixel streaming projects to date. He also loves data and metrics. So he's got a very refreshing and comprehensive approach towards pixel streaming projects. I know we'll definitely get into it later. And David, thank you for that overview. All right, moving on. Next we have Jacob. It's all yours.
Hey, everyone. So my name is Jacob Feldman. I am engineer and solutions architect really for CoreWeave Cloud. And I'll give a little background on myself, but I first want to talk about what CoreWeave does and why I'm here, right?
And Jacob, you've got a double mic going on. There's a little bit of echo.
How about that? A little better?
We can still hear it a little bit.
Let me see what I can do.
Oh, that's getting better.
Better? I can just turn the volume down a little bit while I'm talking. Is that all right?
It still sounds about the same, but we can understand what you're saying.
All right. Well, I apologize for the audio. Hopefully things improve. I have my system volume down, so I'm not really sure where an echo would come. But regardless, so CoreWeave we call ourselves a specialized cloud. And what that really means is when you think about the places that you deploy infrastructure today in the cloud, those are hyperscalers generally, people like AWS, GCP, Azure. And those guys, they are what we call generalized clouds because they will serve any use case. They'll hand you a CPU for just about anything. So if you want to, host a website, you want to, create a file server, whatever, right? They're there to provide compute for that, right? To the point where, the other day, AWS had an outage and I couldn't get into my gym, right? Because my app wouldn't work, right? So CoreWeave, we specialize in a few particular fields. So we work with clients across verticals such as VFX, rendering, media, entertainment, which is my primary focus, batch processing, AI, medical discovery. And we really focus on those and try to design solutions, try to provide infrastructure that is going to work the best and scale the best for those particular use cases. Now, of course, pixel streaming is one of these use cases as well, and that's why I'm here. We are very passionate about providing infrastructure for many teams doing many things across pixel streaming, from the folks building pixel streaming platforms for others to utilize, like Eagle, or for folks who are creating their own infrastructure backend projects. We are open doors for everyone who's interested in creating these worlds using pixel streaming. The largest differentiator, I would say, for our platform is that we provide GPUs at scale, a number of GPUs. We have 10 different SKUs within NVIDIA's lineup, and generally that means when folks come to us, we're able to scale them and scale their experiences bigger and better than they could elsewhere. Right? So to put aside the sales pitch for a second, I'll describe a little bit about what I do. So prior to CoreWeave, I was actually a virtual reality developer in Unreal Engine, primarily focused in AEC. And the reason I initially joined CoreWeave is I was on a call with two of our founders, and they showed me a demo where they had at the time utilized K-Serving, which is a Kubernetes-based scaling platform to scale pixel streaming up and down automatically. And I saw this demo, I was like, these guys are doing something cool. So I joined CoreWeave, and ever since have been working on a number of different initiatives and trying to proliferate, especially Unreal Engine scaled on top of Linux and Kubernetes, which has been definitely a challenging project, but one that we're really excited about, and we're really starting to see results. So I think there's a lot of exciting stuff going on across this space, and I'm really excited to be here to chat about it.
Wonderful. Thank you for that intro. And I actually remember that demo. I got to see it too. And even our CTO too was like, no way.
Exactly. And since then, obviously, things have gotten more sophisticated. Since then, we've developed new solutions, and there's just so much happening every day. It's a very exciting place to work at.
Absolutely. We did have a question come in for you, Jacob. I like this one. How much data will be used in 10 minutes when playing the metaverse on a mobile phone?
Yeah, well, so I think this is actually interesting because there are a couple interesting restraints that people don't generally think about when it comes to scaling pixel streaming experiences. I would say, particularly from an infrastructure point of view, people don't really realize if you have, 1,000 people all playing, a game within a data center, the network constraints of streaming that out of a data center is already a challenge. Then to get that to your end user with low latency, with consistent packet timing, stuff like that, which is usually very critical for games. It's eased a little bit by WebRTC and some of the technologies that are behind pixel streaming. It can be quite challenging to try and diagnose. It's very challenging to say why one user experiences one thing versus another. And I'm sure a lot of these guys understand that challenge. I would say that Bosco's kind of estimation, 50 megabit per second is, you definitely would not want to have less internet bandwidth than that. But I would say, a pixel stream experience can probably pull 10 to 15 megabit pretty easily, at least, depending on the resolution and decisions made by, folks who are scaling the application on the server end. So I would say if you're playing for an hour, you can do the math there. 10 megabit, which is about 2 megabytes or 3 megabytes. Multiply that out by seconds in an hour, and which is, I don't know, I'm not going to do that math in my head, but you can certainly figure that out. Regardless, it's definitely interesting to think about these things because pixel streaming as a medium is really an accessibility layer over a lot of the amazing work that people have been doing in Unreal Engine, doing in real time, and being able to stream highly accessible, highly scalable experiences, I think is going to be a major revolution. So definitely these sorts of questions about, is my data cap, am I going to reach the data cap on my cell phone plan, are very relevant.
Yeah, absolutely. And thank you very much for that response and for the intro, Jacob. Okay, we will go ahead and move on to the next section of the show, which is panelist perspectives. And we have prepared some questions in advance that are geared towards questions that are relevant to each panelist's experience. So we'll go ahead and begin to explore those. And of course, if you have any questions that you would like to add to these, please just submit them into YouTube and we will prioritize them. So Bosco, we have you first. To begin to understand your experience within the metaverse, especially when it relates to pixel streaming, because you are a pixel streaming veteran. How have you seen pixel streaming applications evolve over the last 3 years?
In the early beginning, I would say it was a lot in terms of architectural visualization, so that architects could really, if they created something, they could invite their probably future customers, for example, to show them around the building. Then I think automotive is something which is a killer use case, like for the whole car customization tools or solutions which are out there. I can remember back in the days it was like, you could do something, but now you really can get into the car, have a really proper overview of how the car looks like, and when it comes to the design aspect and the visualization of it, it's really cool. And so this is growing, and I was starting, as I said, back in 2020, because I think I thought to myself, hey, there needs to be some kind of solution which enables it that I can put a AAA experience on the cloud. This was my idea, and everybody was like, "Yeah, you're nuts, Bosco. This won't work at all." And I was like, "Oh, why not? Let's give it a try." And everybody was, "Yeah, do it alone. You will fail." And I was like, "No, nothing is impossible." So I really took a deep dive in how things are working, because I didn't have any clue at all. And then, of course, I came to WebGL, but this was not that suitable for the Unreal Engine powered world, which I created. So I needed to find another solution. And since I took a deep dive into cloud technologies, I then, kind of discovered pixel streaming and experimented with it. And the first tries were, quite frustrating. But then suddenly it was working somehow, and I saw the opportunity, and I said to myself, "Hey, this is a killer. If everyone really can make it happen to stream the 3D experiences or even virtual worlds, then it's a killer." And I mean, for instance, a couple of days ago, there was a huge Meta festival, a huge live conference, and they had, in addition, a virtual experience of the whole show, and it was all pixel streamed. And I think pretty cool, because this shows the opportunity to really have like a conference streamed on YouTube, but on the other side, you had really a 3D experience where you could dive in. And this is immersive entertainment and immersive education somewhere. And this is a huge power. And that's why I think, I mean, even last year, same time of this year, I was talking to a lot of people, and everybody was like, "Yeah, pixel streaming, forget pixel streaming. We go with the client, because pixel streaming, this has no future. It's much too expensive and won't work." And I said, "Hey guys, yeah, maybe. I mean, I don't care, because I just do what I do. But I today I can." Really say everyone give it a try, because it's really a power behind it. And I mean, have a look at the automotive. For me, is the one of the best showcases right now when it comes to pixel streaming, for example.
And we did have some questions come in for you, Bosco, and we may explore one right now and then more towards the end of the Q&A. And this question was, when you were giving your screen share, they said, assuming this is multiplayer, and how many concurrent players are you planning for?
So yes, it is already multiplayer. We tested it already with 10 people, because I mean, you need to be it is not that how do you say it? It costs a little bit more money to host those kind of applications. And but we tested it with 10 concurrent users, and actually we are now having the right infrastructure where we can scale. And the good thing is that each pixel streaming instant is really an instant. So each user gets, so to say, a hardcore PC out of the box as one instance, and that way, I mean, it's cloud technology. You can scale it in the background, and if you have 100 persons, you can get 100 persons in there. But this, of course, depends and always related to the virtual world or experience which you're creating. Because if you just have a tiny experience, it wouldn't make sense if you put 100 people in there, because then everybody's like, just standing in their way. But if you like the Meta City, which I just showed, I can like, my vision is that at the end of the day, we will host like 1,000 people maybe in there simultaneously, something like this. I mean, this is a challenging thing, but as I said, nothing is impossible, and the technology is there. It's just about putting the pieces together in the right way, and then I'm pretty sure it's working, definitely.
Wonderful. And thank you for your answers. We'll move on to David. So David, I know that data and metrics are an important piece of some of the projects that you've been involved in. Can you maybe share some examples or why you decided to add data and metrics into your experiences? Did that come from a request from the client, or did you just know that was going to be something that would be that would make the experience more powerful?
Definitely. I mean, I'll show one of the examples first on the screen. So one of the examples that we've worked on predominantly through the life of Invidai is a project for Milwaukee. And whenever we work on these kind of large projects, especially ones where we need to look at kind of return on investment and actually the effect that it's having on the user base. We need to consider the data that we're capturing. So it plays a massive part in both how we develop, how we sort of innovate on top of these projects. So this is one of several kind of experiences we've done for them and events. And each time we've managed to do better than the last one by taking this data and acting on what we've recorded. And as I said, it's completely integral to showing what the return on investment is there for these for Milwaukee in this particular instance. So.
And can you share a little bit about how, or perhaps maybe some of the data bits that you are capturing, and then what's being used with that data?
Yeah, so I can't share too many specifics, but
Sure.
obviously with experiences like this, you can capture the amount of users you're going to capture the amount of time that they're going to be spending in these type of experiences. And I think what's interesting is we've tried a number of different ideas, not just with this project, but with other projects as well. Sort of looking at more cost-effective solutions, so like kind of OpenGL and not pixel streaming, and then kind of looking at the pixel streaming solutions as well. And we can see, especially with the pixel stream, where we've got the higher quality and the better accessibility, those projects seem to do much better in terms of users actually spending time in there and people exploring a lot more. It seems to be that if you do have those high quality experiences, people are interacting with it a lot more. And if you're not capturing that data, then you can't tell from that kind of basic perspective. But we are tracking sort of more complicated project sort of data as well about where users are walking to, etc. So.
And I heard you mention OpenGL. Do you have any ideas or thoughts around maybe what are the advantages, disadvantages of OpenGL, WebGL versus pixel streaming? Why would I choose one or the other?
Definitely. I mean, from a business perspective, when we have these talks, obviously you've got to consider all different scenarios, right? Pixel streaming is definitely one of the most accessible, and I think that's one of the biggest drivers for pixel streaming, and the quality as well, making it accessible to all people on all devices, making it accessible to mobile as well. Whereas if you're developing on OpenGL, you have to make sure you develop for every platform. It can eventually become actually more costly, and the quality isn't necessarily there. And not all devices can sometimes run these OpenGL applications in browser. Again, making the pixel streaming sort of application looking even more enticing again with that accessibility. It can be a tough one to manage as well at an enterprise level. Pixel streaming, especially when you're kind of when you've got it in Azure, GCP, etc. It's much easier to manage remotely from a DevOps perspective. Whereas if you're having to load an OpenGL package, and get that distributed out across the whole of the European region, it can be quite difficult sometimes to manage. And again, sometimes it's not going to be running well on other people's machines, and you really do have to test it a lot more. Whereas again, pixel streaming, you know what the hardware it's running on. It's solid. It's going to be accessible as long as they've got a good internet connection. The stream will be solid. So.
Awesome, and thank you very much for that, David. If you would mind turning off screen shares, we're staring at a single static image. But that brings up a very good point. Is there's lots of ways of delivering content on the web, and not one is necessarily better than the other. It just depends on what you're trying to do.
Definitely, yeah. So, and that comes back to what Oscar was saying in the kind of automotive space with the configurators, right? A lot of what we're talking about here are real-time solutions. So, the automotive space have definitely shown some great configurators in sort of their car models, but then how are they following up with that with the data again? Going back to that point, how are they following up with those customers? Are they going to make a purchase? Is that having an effect? And from what we can see on our side, upping that quality definitely has had that kind of effect with the projects we're working on.
Absolutely, yeah, and it's so important, and you guys do it very, very well. Thank you, David. Next, we will move on to Jacob. And so just, a few questions for you, Jacob. So how is CoreWeave responding to the growing interest in cloud streaming?
Yeah, I think it's there's a couple things happening simultaneously, right? So one of the first things that come to a lot of people's minds when you talk about just game streaming in general are platforms like what used to be Shadow, or platforms such as NVIDIA GeForce Now and Xbox. I can't remember what they call it. The Game Pass that also has their version of streamed applications. So there's a bunch of there are a bunch of services like that have come up over the years, and I think the largest challenges that they've faced have been one, access to infrastructure that really supports it, and people's internet connection, right? Those were the two biggest difficulties that those services faced, because there was a lot of excitement, for example, when Google announced, they were going to create a game streaming service and it was going to be accessible to everyone. Everyone was so excited to play like, Tomb Raider on their cell phone. That sounded awesome, right? But I think what generally happened was, GCP, Azure, they will run everything on the same two GPUs in their entire data center. So they usually use a T4 or something like a V100, which is really an AI, inference GPU. And that physical infrastructure limited them in terms of, what sort of experiences they could provide. Because if you were logging on to, GeForce Now, or for whatever reason, the Google product is escaping me. Someone maybe can chime in to remind me what it was called. But regardless,
I guess it's Stadia or something.
Yeah, Stadia. Thank you. Yeah.
Yeah.
So everyone who logged into Stadia was expecting, I'm going to turn on ray tracing, right? I'm going to turn on all these features because, they're paying to have the best experience delivered to them, right? And then you log in and you can't do that, right? On top of, other issues, right? So I think that's a big challenge that is ongoing in a lot of places in the space. And like I mentioned earlier, we have, like a dozen NVIDIA SKUs, and usually people, when they come to us, find that they can deliver the application the way they want. I think the other big challenge, obviously with pixel streaming, is just, the distribution of, it's the difficulty of scaling up these applications over, infrastructure is obviously extremely complicated, but also across regions, right? I think a lot of people, imagine that, I can run my pixel stream application in New York and it'll be fine in, Tokyo. And it's unfortunately not the case, right? So those are, I would say, the two biggest challenges that we face day to day when it comes to pixel streaming. But there's just so many cool projects and so many cool things people are trying in this space to facilitate that, that I'm quite excited for what's to come. I do think that services such as, like Stadia, I don't, I'm not going to profess to know what the future of those kinds of services are. Certainly they were, heavily invested in. But certainly I think the direction that people have gone with pixel streaming goes to show that, people don't necessarily need, every game in their library streamed to them, right? But there are certain things, events, configurators, and some of the use cases we've already talked about. Those sorts of things make a lot of sense because they are in line with other experiences that we're, consuming, right? So we go to a website and it's in line, right? You click a link and you are playing a game because it was part of a larger experience, right? Which they were delivering to you over the web. I think that makes a lot of sense. Not to mention all the sort of enterprise use cases for this that go on behind the scenes and, the general public will never see, but don't rely on, needing, aren't just for, playing Tomb Raider, right? So there's a lot of cool stuff going on there. I think I lost a bit of the, I apologize, I got a little off track, but hopefully I've answered part of that question.
Definitely. And so we took a poll during the channel or during the show, and the question was, what is the future of pixel streaming in the cloud? And we were divided right down the middle with 50% saying Windows and 50% saying Linux. So can you be our tiebreaker?
Well, okay. So I have a lot of opinions on this, so I'll try to be as concise as possible. But I would say the biggest difference you find with Windows and Linux is Windows adds a ton of complexity. Actually, people think it adds all this ease of use, right? And I think people think, oh well, I have Unreal Engine installed in Windows. I'm used to editing Unreal in Windows. I'm used to doing everything in Windows, so it must be easier to deploy my pixel streaming application in Windows, right? But as soon as you attempt to scale those experiences, you realize that the Windows platform was never designed for data centers, really. Like, yes, there's Windows Server. Windows Server has not been a hit compared to things like RHEL and what IBM and these other folks are doing with enterprise Linux compared to Microsoft's platform because of things like licensing, right? Trying to license Windows when you're running 5,000 concurrent users, A, is expensive, and B, is complicated. There are actually, one of the things we learned going out to try and support Windows users is that when you go out and talk, there's no one to talk to about Windows licensing, right? What you go to is a consulting/lawyer firm that specializes in Windows licensing, right? So that should tell you something about the state of the Windows platform when it comes to scaling things up, right? So it's more expensive, it's more difficult to license, and it's also more difficult to orchestrate in general. And that's in general, right? That's not true on every platform. So if you go to AWS or, of course, Azure, it's going to be a lot easier to to work with Windows than it would be on our platform, for example. So our platform is Kubernetes native, and for those who don't know about Kubernetes, Kubernetes is an orchestration platform. Really, it's about placing workloads on machines, across thousands of machines or many regions, data centers, etc. Right? If you have a lot of work to do, you need something to tell where that work is going to be done. So that's what Kubernetes does. But it's a very modern orchestration platform that runs on top of Linux, and it utilizes this technology called containerization that some people may have heard of. But containerization, when we talk about orchestrating, is really the process of creating workflows, if I have work to do, I want that work done in a consistent environment, and I want that work done quickly, right? Those are kind of the two big things that containerization does for a lot of people. Now, it's not a silver bullet. It adds complexity, of course. And for those folks who have never, looked into containerization, it's complicated. The process of converting pixel streaming into a containerized application was extremely complicated. Thankfully, we have folks like Adam Wren over at TensorWorks and their team that have done a lot of amazing work on this to make pixel streaming, work inside of containers. They're also now the maintainers of pixel streaming for Epic Games. But I think that once you have it in this environment, so once you have containerized Unreal Engine and you can deliver applications via Kubernetes or in containerized environment, what you get is something where if previously you were used to scaling up at, okay, we can launch one instance every 30 seconds, or if we need to allocate 5,000 users for a big event, we need to go an hour, 5 hours in advance, tell Amazon we want 5,000 instances, and they're just going to start spinning up, kind of randomly over 5 hours, and then we're paying for those for 5 hours. It turns into a whole mess, right, when you try to do this kind of thing. So with containerization, on the other hand, you tell it, I want 5,000, and 30 seconds later, you have all 5,000 up, right? And that's really the big difference here with Linux. Windows has its advantages, right? Windows was the native platform for DirectX, right, which is really where a lot of game development happened for a long time. It used to be DirectX or OpenGL, and if you had to choose between the two of those, you'd probably choose DirectX. But thankfully, we have some more modern, graphics APIs like Vulkan nowadays that are kind of bringing the OpenGL sort of standard into modern days. And Vulkan, being completely compatible on Linux, really opens the doors to the sorts of experiences that you can create on the Linux platform. So if you put all this together, I think what you'll see is that you get the scalability and the accessibility, meaning cost accessibility, right? If you're not paying for licenses, you're not paying for instant spin up times, you're not paying for all these things, you get cost accessibility, right? If you put together, the performance you get, you actually can get better performance when you don't include things like the Windows hypervisor, or if you go to Azure, you're going to have 3 or 4 layers of hypervisors, meaning these essentially layers of compatibility between their infrastructure and your workload, right? If you get rid of all that, you actually will get more performance. So if you put all these, things together, what you'll see is that the Linux platform really offers a lot for scalable pixel streaming, right? Because if we're talking about scalability being an important factor, which is, I think, a very important factor when we're talking about how do we deliver experiences to as many people, to as many devices as possible, I think you'll come to see that Linux is kind of the way things are going, at least.
Yeah, and it's a very complicated question that has many things that need to be considered. But thank you for exploring that with us.
Yeah, I will make one note to say, absolutely, not all applications are compatible with Linux, and that's one of the big efforts that's ongoing, I think, in this space to say, because like I said, historically everything was DirectX, everything was Windows. So, for example, in Unreal, you have all these plugins developed by thousands of developers that now have to go out and add Linux compile targets, have to add all this technical, they have to pull in their engineers now to make these changes, right? And there's a lot of work to do there still. So I'm not saying it's today, but it will be, is my estimation.
Awesome. And thank you for being the tiebreaker. We will move on to Ludwig, who is our digital twin expert. Ludwig, just, question to kick it off. We've seen some rapid growth in the digital twin space. Are there any use cases that you find particularly powerful in the space?
Yeah, I mean, depends on, like, if you're thinking about with pixel streaming specifically, because there's the combination of digital twins and pixel streaming, why you would do, one or the other. And there's a lot to unpack there. I mean, at first I would say that, the reason why the digital twins are taking off is because the technology is there all of a sudden. It hasn't been for a long time. Like 10 years ago, forget about it. 5 years ago, things were like starting to happen. Because having a digital twin run in a pixel stream cloud environment, there's a lot of moving parts there that all need to sort of fit together. So I think now with the release of Unreal Engine 5, you finally have the last piece with a game engine that can build a client that can scale to insane amounts of data and very large outdoor areas, like for instance like global scale, like Earth scale. You can fit the entire Earth in a single Unreal Engine model now, like coordinate system wise, because Unreal Engine runs natively on double precision now, which Unreal Engine 4 didn't. So realistically in Unreal Engine 4 you were limited to real world like extents of something like 10 by 10 kilometers or around there, and if you went beyond that, things started going weird because of the single precision. So now you can have like digital twins within digital twins, kind of. You can have a country scale layer, even Earth scale layer, country scale layer, city scale layer to building scale layer that all integrates with different systems on the back end. You can have open information coming in from like national transportation systems about the state of the roads and the railways and all of that, and go down to city scale for like city environment pollution data, and go into a single building and integrate with a building management system for that system and display data. Of course, creating an experience like that is very complicated. You need to have all the data coming in from the back end. But I think there's a real strength with pixel streaming, because if you have a client running the application, you need all of that data streamed from either packed into the client, digital twin of the entire earth.exe, or you need to stream all of that from the cloud backend to the user. But if you put all of that in the cloud, like the same cloud backend, you can just stream it within the cloud to the pixel stream instance. So it's just very predictable. So the only thing that goes out to the user is the pixel streams. Okay, 10 megabit pixel stream goes out to the user. and you have the target system for your application defined, you don't need to worry about min specs. And yeah, all of that stuff really, comes together to make like creating huge scale experience with huge scale diverse data sets being streamed in possible right now. And it's super exciting.
Yeah, so when we're staring, up the mountain of a digital twin project that involves pixel streaming, what is that? I mean, how do you get started? What is that workflow like? When do you pixel stream the application? How do you go about the planning of something like that? Or what would you recommend for anyone that's embarking on a digital twin pixel stream project?
Well, I mean, each digital twin is unique. I would say you need to define your in data sets. Like, where's your data coming from? Is it real-time IoT data through like IoT hubs or digital twin platforms? Or are you loading in like static BIM data or point clouds, or are you using like AI predictions? So where's that coming from? Then you need to make sure that your, for instance, Unreal Engine client talks to all of that. And yeah, so really you there's no like one-click digital twin pixel streaming solution there. So you need a whole team that has the full knowledge of all of that stuff to pull anything off at scale, I would say. But it's possible. Start with a giant architectural diagram, I would say. Work from there.
And so and that's a great point. So what are some of the team strengths or some of the skill sets and team members you would maybe need for a project?
Well, probably you would need to run on some sort of cloud platform. I mean, you can set up your own data center, but I wouldn't. So a cloud team for the for the infrastructure. If you want to run on AWS or Azure or GCP or whatever, you need that. Then you need the Unreal Engine knowledge. Also, within Unreal Engine, there's a bunch of skill sets you need. You need the technical artist. Probably you would need C++ developers to create plugins and interfaces to talk to the cloud backend, because that's not there out of the box in Unreal. And planning. So yeah, a team, at least you need a team of a handful of people, I think, if you need to encompass all of that. And the more diverse data sets, the bigger the projects, the more the complexity grows.
Absolutely. Yep. And I know they can get complex very, very fast. Any other thoughts or comments, Ludwig?
Yeah, I can talk for hours about this, but I notice we're running out of time here, so I'll just leave it at that.
Wonderful. So thank you everyone on the panel for being with us today. I mean, you guys have such an amazing wealth of knowledge. It's really a treasure having you all together in one space. I know that we did not get to some questions from the audience, so what I'm going to do is we catalog them, and then I'll send them to our panelists, and then try to get answers, and then we'll post them somewhere like LinkedIn or Facebook, or we'll figure that out. But we're not disregarding the questions. Everyone, thank you so much for being here today. It was an amazing experience. We appreciate you all, and thank you all for tuning in, and we will catch you on the next show.